important practical informations about the autonomic nervous system, especially things that are related to pharmacology and drugs that can be applied on autonomic receptors. I'm trying to share now the file for the introduction of the experiment that we are going to do in a simulation pattern. That means that we are going to apply certain drugs that affect the autonomic receptors on the eye of the human, the simulated human. Can you view the shared file together?
Can.
You can.
Today there are some students at the lobby.
Yes, that's why. Yeah, okay, I'll try to admit them now. So far we have 38 students, with me 39 participants. Yeah. Okay, so for this experiment, or for this drug application, to understand the autonomic receptors and the drugs that can act on autonomic receptors as agonist and as antagonist, we are choosing the eye. The eye is chosen because it is an organ that is supplied both by autonomic, but both by cholinergic and adrenergic nerves. So it carries in its smooth muscles both cholinergic receptors, muscarinic receptors, and adrenergic alpha-1 receptors. And both these, the action of both these receptors can be viewed externally, yeah, without the need of any anatomical dissection or dissection. Yes, so that is the important fact about the eye that makes it a good example to be illustrated in this simulation. So in this part one, the first session, we are going to test the drugs, the autonomic drugs, to be applied on the normal eyes. And in the next session, we are going to wait. Let me let the neural inside. Okay. So in the next session, we are going to have some application of the drugs, the same drugs that we are applying now on the normal eye. We are going to apply it later on the disease eye, the disease or scale. So what happens if I increase the light intensity? There will be pupillary. What will happen to the pupils?
Decrease in size.
Okay, decrease in diameter or decrease in size. This is what we call miosis. This is what we call miosis. And then here, you see that in the middle, there is the crosshair measuring device. And we can check on each side how much is the dimension of each, or the diameter of each pupil. So here from the right side, on the left side of the patient, the left eye of the patient, how many units do you see the scale, the measure of the diameter of the eye of the pupil? Can you tell?
Wait, Prof. I'm trying to count it.
Okay, just the pupil, huh? Not the whole eyeball. Just the pupil, the black one.
4.
4 units. Okay. So here's what we're gonna do. We're gonna measure this one, and we're gonna compare it to the other side. So the other side is how much?
Also 4 units.
Also 4 units. So that's why this is Miss Normal. That's why this is Miss
Muscarinic.
Muscarinic receptor. Okay. Muscarinic receptor on which muscle? The circular muscle or the radial muscle of
Circular muscle.
circular muscles? Thank you so much. Thank you so much, Zulfakhri. You are very right. You are very right. That is the important thing about physiology. Understanding physiology will help us understand pharmacology. So that's why we are asking these questions before we start the drug application. Amira, can you see what happened to the pupil size?
It's dilate.
Pupillary dilation. Pupillary
Yes.
dilation. So
Dilation.
in pupillary dilation, can you tell us the measure based on the crosshair that I'm using here? The measure, the diameter measure from here, from the one side to the other? Horizontal.
16 unit.
Okay, 16 units. This is for the left eye. We go to the right eye. Berapa unit?
16 sama-sama.
Okay, 16 sama. So that means that the pupils are symmetrically are symmetrical in size and symmetrical in diameter. That's why the patient is called Miss Normal. So thank you, Amira. So yeah,
Did you
yes,
hear me, Paul?
yeah.
I think it is alpha 1 adenine.
Alpha 1 adrenergic, alpha 1 adrenergic that causes the mydriasis or the pupillary dilation. So that's why we said in the beginning the eye is dually innervated, which means that it has both sympathetic and parasympathetic nerves reaching the eye. And then the sympathetic is supplying a norepinephrine, a neurotransmitter, to alpha 1 receptor on the radial muscle of the eye. That's why it causes pupillary dilation. Radial muscle of the eye causes pupillary dilation, while the cholinergic innervation to the eye causes miosis or pupillary constriction by acetylcholine on the circular muscle of the eye. The adrenergic is stimulated by decreasing light intensity. The cholinergic is stimulated by increasing light intensity. Is that okay? If we ask the patient to blink, we will have the blinking reflex. The blinking reflex is important to see the reaction, the speed of the reaction of the pupil to blinking. So the reaction of the pupil to blinking is either symmetrical or asymmetrical. So this is a normal person or normal patient in which the blinking reflex causes symmetrical response or speed of response to increasing light intensity. You see, I've increased the light intensity and we are going to apply certain drugs. The list of the drugs are available here by the drop-down list. Okay, so we have amphetamine, we have atropine, we have cocaine, we have phenylephrine, we have physostigmine, and we have pilocarpine. Okay, so our task is to know first these drugs, the mechanism of action of these drugs on which one is cholinergic, which one is adrenergic receptor stimulant or antagonist. So first, the receptor that will be affected by each drug, and whether it is affected by stimulating the receptor or antagonizing that receptor. And the other fact that we need to know is whether it causes miosis or mydriasis, which means pupillary constriction or pupillary dilation. Okay?
Yeah, doctor.
Okay. So pilocarpine here, is it a muscarinic or nicotinic receptor agonist?
Again, doctor.
We said we are talking about pilocarpine here.
Agonist.
Agonist. So does it
Yeah.
cause? So which muscle of the eye does it affect? The circular or the radial?
I think radial.
No, it affects the circular
Oh.
muscle. It affects the circular muscle of the eye
Yeah.
because the muscarinic receptors are on the circular muscles of the eye supplied by which nerve? Sympathetic or parasympathetic?
This
What is meiosis? Pupillary dilation or constriction?
is the constriction.
Okay, constriction. That is what we are going to try just now. Okay, that is what we are going to try now. So here, we are going to administer. You can see here the administration. The name is pilocarpine. We are going to click here, and you can see that what happened to the eye is pupillary constriction, and we can use the measuring crosshair. How many units? Here we can see on the left side. Lee, how many units? On the
It's
left,
5 units.
5 units. And for the right eye of the patient?
5 also.
5 also. So it is symmetrical pupillary constriction by the admin. We can also remove and reapply to confirm. You can remove and this is the benefit from using the simulation. You can always remove and reapply. So in this case, we call the type of meiosis here. We call it active meiosis. We call it active meiosis. Why do we call it active? Because it is caused, the pupillary constriction is caused by direct stimulation of the pupillary constrictor muscle of the eye, the circular muscle of the eye. If the pupillary constriction is caused by paralysis of the radial muscles, because we have 2 muscles, each one is pulling to the opposite side when it constricts. So the pupillary constrictor is trying to reduce the diameter of the eye. The radial muscle of the eye is the pupillary dilator, trying to pull and increase the pupillary diameter of the eye. So there are 2 muscles. Each one is pulling.
Oh, Professor,
Yes.
can you repeat again the passive meiosis?
Okay. Okay. So we have 2 muscles on the eye. Each one of these muscles is counteracting the action of the other. So we have the pupillary constrictor muscles trying to constrict the eye. The pupillary constrictor muscle trying to constrict the eye. Okay? To make the pupil diameter smaller. And there is the pupillary dilator muscle, which is the radial muscle of the eye, which is trying to pull the pupil outside and then make it larger in diameter. Okay, so these are 2 muscles acting on the same time. If we stimulate one muscle, like we stimulate the constrictor, we cause active meiosis. If we stimulate the radial muscle, we cause active mydriasis. All right, but the other way around, if we paralyze the radial muscle, that means there is no more pupillary dilation. We end up with, again, meiosis, but this meiosis is not active, it's passive. If we paralyze the constrictor muscle of the eye, that means relax the constrictor muscle, the force becomes 0. So the only muscle that will work is the radial muscle of the eye. So we end up with passive mydriasis. So there is active meiosis, active mydriasis, passive meiosis, and passive mydriasis, depending on whether we are stimulating the muscle to contract or we are paralyzing the other muscles to contract.